Assalamualaikum. My name is Muhammad Nur Sufian bin Sudin with ID MA18263. So we are from BMM3531 Section 1 Group 1. In this video, we are going to present and discuss about the experiment of air conditioning. An air conditioning process which consists of maintaining a living space or facilities at a desired temperature and humidity was analyzed using an conditioning laboratory unit. In this experiment, each group is required to analyze the experiment based on the distributed test experiment and data collected by the lecturer. So at the end of this experiment analysis, we shall utilize the knowledge gained in this experiment and apply in the daily life by applying the higher effectiveness in manipulating the higher temperature to required range for the best performance. So as you can see, this is the schematic diagram of the air conditioning system that consists of four main parts, where are the condenser, compressor, evaporator and also the pump. So air conditioning is that process used to create and maintain certain temperature, relative humidity and air purity condition in indoor space. Any air conditioning system must be effective regardless of outside climatic condition and involves control over four fundamental variables. The main function of an air conditioning system include heating and cooling and humidifying and dehumidifying in order to create the desired indoor air condition. So in this experiment, we should be able to identify the components that make up the air conditioning, evaluate specific monitoring characteristics such as flow speed, pressure and temperature reading, and coefficient of efficiency. Third, be able to determine suitable human comfort condition based on the air humidity. The lastly is the air temperature from the refrigerant and refrigerant pressure under constant fan speed. So I think that's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Ahmad Ikmal bin Asfarizal and my ID number is MA18142. So today I will present a little bit about our literature review. So based on figure 3 at the right side, the label component are based on compressor, condenser, expansion valve and evaporator. So for the process 1 until 2, refrigerant at point 1 is low temperature and low pressure gas in order to be able to use it again to achieve the refrigerating effect continuously. It must be brought back to liquid form at a high pressure, and the first step in this process is to increase the pressure of the refrigerant gas by using a compressor. So next, process 2 to 3 consists of condensing process, which is the refrigerant leaves the compressor as a gas at higher temperature and high pressure. In order to change it to a liquid, heat must be removed from it. This is accomplished in a heat exchanger called the condenser. And next, expansion process, which is consists of 3 to 4, which is at point 3 in liquid state with a relative high pressure and temperature will flow through a restriction called the flow device or expansion valve, and the refrigerant loses pressure going through the restriction. Therefore a small portion of the refrigerant flashes, which is vaporized into a gas, and in order to vaporize it must gain heat which is take from that portion of the refrigerant that did not vaporize, that resulting in cooling by a low temperature. And next, vaporizing process, which is consists of 4 to 1, which is the refrigerant flow through a heat exchanger called the evaporator. The fluid to be cooled is at a slightly higher temperature than the refrigerant, Therefore, heat is transferred from it to the refrigerant, producing the cooling effect desired, and the refrigerant boils because of the heat it received in the evaporator. By the time it leaves the evaporator at point 1, it is completely vaporized, and the refrigerant has thus returned to its initial state and is now ready to repeat the cycle, which is in a continuous manner. So the objective for this experiment is to determine the suitable human comfort condition based on the air humidity and air temperature from the refrigerant temperature and refrigerant pressure under constant fan speed at 60%. And next, to calculate the coefficient of performance before based on the refrigerant temperature and refrigerant pressure at the human comfort condition when constant fan speed is 60%. I think that's all from me. Thank you.
Thank you, Wan Ahmad Iqbal. And now I will continue to present about the experiment, equipment material and procedure. As you can see, the figure is the unique construction for air conditioning unit model for model AC01. The label of number 1 is the control panel, number 2 is the expansion valve, number 3 is the orifice, label number 4 is the DP transmitter, number 5 is the heater, number 6 at the middle is the pressure switch, number 7 is the refrigerant condenser. For the number 8, that near the refrigerant condenser is the refrigerant compressor. At the bottom of the label is the refrigerant flow transmitter. Number 10 is the humidity or the temperature sensor. Number 11 is the fan. Number 12 is the humidifier. Number 13 is a sight glass. And number 14 is refrigerant pressure transmitter. And number 15 is the filter dryer. Next, for the experiment procedure. First, for the general startup procedure, first we must perform a quick inspection to ensure that the unit is in proper operating condition. 2. Make sure the humidifier water supply is connected to a tap water source. 3. Connect a drain hose to the condensate collector at the bottom of the air duct. 4. Turn on the power supply switch. 5. Switch on the main power switch for the air. After that, for the procedure, first we must switch on the radial fan and run the air velocity at 15% of the maximum airspeed. Second, we must switch on the refrigeration unit. Third, allow the system for approximately 15 minutes to reach a steady state. Fourth, record the temperature TT1, TT2, TT3, TT4, PT1 and PT2 of the refrigerant circuit and obtain the refrigeration flow rate FT1 from the refrigerant flow meter. And for the general shutdown procedure, first we must switch off the preheaters and reheaters and allow the heaters to cool down with fan on. After that, turn off the fan speed control knob and then the fan switch. After that, we must make sure that all other switches on the control panel are switched off. Fourth, switch off the main switch and power supply. And lastly, we must close the tap water supply. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Mashaki and I will proceed with result and discussion. So for result 1, regarding to the first objective, which is to determine the suitable human comfort condition based on the air humidity and air temperature from the refrigerant temperature and refrigerant pressure under constant fan speed of 60%. So this is our data, which is you can see that the the relative humidity and air temperature at preheater and reheater of 1 kilowatt is the best choice, is the best, because as we know, the range for best human comfort condition for air temperature is from 22 until 27 degrees C, and for relative humidity is from 40 to 60%. So we can see that at preheater and reheater of 1 kilowatt, the data is inside those range. So we will choose energy consumption of 1 kilowatt for both preheater and reheater for the next step. For result 2, regarding the objective of to calculate the coefficient of performance based on the refrigerant temperature and refrigerant pressure at the human comfort condition under constant fan speed at 60%. So, as mentioned before, we will focus on the energy consumption of 1 kilowatt for both preheater and reheater. So we will extract the data um, for to find the entropy and other data after this. And this is the refrigerant cycle and also the pH diagram, where we will refer this pH diagram to find the enthalpy for each point, which is starting from point 1 until point 4. So starting from state 1, which is it is we have to refer the saturated refrigerant table, which is table A12, to find the H1 value by using the pressure and temperature, and we will got H1 is 260.01 kilojoule per kilogram. For state 2, we can see that P2 is 726.69, which is higher than PT1, which is 675. It means that it is located at superheated refrigerant. So we have to refer table A13 to find enthalpy 2, which is we got 267 kilojoule per kilogram. So note that there are also a theoretical value of H2, where we will find it to compare the COP. So to find the H2, uh, as we know, the entropy for S2 and S1 is the same. Also, the pressure for P2 is the same. Using this information and refer to table A13, we can find H2 theoretical H2 by using interpolation. So the answer is 266.101. For state 3, it is also located at um, um, the saturated refrigerant. So the just like before, we can find the H3 at 86.21 kilojoule per kilogram. And for state 4, the enthalpy at H4 is 85.4 kilojoule per kilogram. Next is to find the coefficient of performance, COP. So the formula is H1 minus H4 over H2 over minus H1. We got 24.98. The value is out of range if compared to the standard value of COP, which is from 3.8 to 6.2. This happens due to the error of taking the reading during the experiment usually happen. And we compare it. So the theoretical coefficient of performance, just like mentioned before, we use the theoretical H2 to find it. So the formula is H1 minus H4 over H2 minus H1, and we got 28.6669. So for the discussion, compare the value of coefficient of performance of refrigerant between experiment result and theoretical result. Based on calculation, explain in your own word why the different result occurred. So firstly, because gross error, which is caused by human mistakes, wrong reading of the measuring scale, and also recording incorrect data. Also because of systematic error, which is external condition of the measuring device, temperature, pressure, vibration, and etc. Next discussion is almost all refrigerant currently in operation are either based on a vapor compression or on an absorption cycle. Could you please explain what is the difference between vapor compression and absorption cycle? So the main difference between a vapor compression and a vapor absorption system is that a vapor compression system uses higher grade energy, such as electrical or mechanical energy to drive the compressor in the cycle, while a vapor absorption system use low grade energy, such as waste heat from the furnace, exhaust steam, or solar heat for the operation of the system. So next discussion is what happened to the coefficient of performance of refrigerant system if refrigerant temperatures that came out of compressor enhanced. So if refrigerant temperature that came out of compressor enhanced, the coefficient of performance of refrigerant system will be decreased, because when the temperature that came out of compressor enhanced, it will increase the temperature difference, that lowering the coefficient of performance of the system. So that's all from me. Thank you.
Conclusion, we successfully done this experiment visually. The experimental result indicated that air can be conditioned to desired level to maintain the health and comfort of the occupants or to meet the requirement of industrial process. In this experiment, we have done to analyze the experiment based on the distributed test experiment and data collected by the lecturer. We also know the knowledge gained in this experiment and apply in daily life by applying in with the highest effectiveness in manipulating the water temperature to a required range for the best performance on every need. We have analyzed a laboratory experiment displaying the basic thermodynamic cycle found in the air conditioning system. We got the measurements of temperature and pressure at each stage in the cycle and gauge the power draw from compressor from the lecturer in charge and make analysis to gain an understanding of how performance and electricity costs come in play for this device.